All right, there, 7th grade scholars. Today's going to be with Mr. Friedline. We're going to start with our very first of many video tutorials on everything you're going to be learning this year. Our very first thing that we went over was prime factorization. Prime factorization is going to basically take 360 or any composite number and break it down into its very essential tiny little building blocks, prime numbers. Numbers that can only be divided by 1 and itself evenly. For a number like 360, a composite number, there's a bunch of different places we could start. I know that 3 will go into this, so I could start with 3. Or I know that I can divide this by 2 because it's an even number. But I'm going to be a little more strategic about it. I see it ends in a 0, so I know I can divide this by 10. Dividing this by 10 will kind of break this down a little bit faster for me. 10 times 36 gives me 360. Now from here I can work on either side. First we'll start with 10. 10 I can divide down into 2 times 5. 2 and 5 are both prime numbers, which means that we have our first 2 prime factorizations that go along with 360. Now we have to go to 36. Well, I know that 36 is a perfect square, and I can do 6 times 6 gives me 36. 6 can be broken down even further to 2 times 3. And again, 2 and 3 are both prime numbers. That means that these are also in my prime factorization. I've got one more left out here all by itself. I can't forget this one. It's the same thing as this. 6 can be divided down into 2 and 3. It can be factored down to 2 and 3, and there we go. I've gotten all the way to the end where I have prime numbers at the very end of all of my factor tree, so I can finally say that my answer for this problem, if I'm doing this in order from least to greatest, would be 2 times 2 times 2, 1, 2, 3, times 3 times 3. We got a nice little lonesome 5 over here, times 5. The prime factorization of 360 is the same thing as 2 times 2 times 2 times 3 times 3 times 5. And if you go through and you actually multiply this all out, you do in fact get 360. These are all prime numbers, which means I must have done this right. To take it one step further, we can put this in exponential notation. That means that we have 2 times 2 times 2, which is the same thing as 2 to the 3rd power. From there we have 3 times 3, which is just 3 to the 2nd power. We have 5 just by its lonesome, so we just multiply by 5. That's prime factorization.